Thank you very much for the invitation. I think it's a very interesting thing that you have your own ombudsman for animals. I'm a bit envious on that, actually. And if I really hope that I can understand more Finnish, because you've got a really interesting program for the next 2 days. So I'm very happy to be asked to come and to talk about the things that really have gone into our research the last couple of years. So I'm going to talk about the keel-borne fractures in laying hens, and I know the audience here is a wide range of people, so I just thought I would start to kind of set up some basic definitions on anatomy and fractures and definitions of the actual problem. So first of all, what is a fracture when terms of medical biology? A fracture is a discontinuation of the bone tissue, so it breaks, and that can be either complete or incomplete. We have these complete fractures here, but also incomplete, and that could also just be small ruptures of the surface of the bone. So that is all defined as a fracture in medical terms. And how do they occur? Well, it's because they are overstretched or overbended in some way. And depending on the age, the bones are more or less bendable. So the younger you are, the more cartilage that is in the bones, the softer they are, then they can bend a bit more. So they are a bit more flexible. You know, we are all born with a fairly soft skull, and that is made of mainly cartilage in the beginning, which ossifies during age. That is the same thing for the keel bone, which I will concentrate about. And the keel bone is also the sternum as we have it here. You can see it here, and that is also marked in blue, and that is the keel. And when I talk about cranial, that is towards the head, and caudal or distal, that is towards the rear of the bird. So, and this is a blow-up of an old anatomy book with the keel bone of a chicken. And we can see there's a bit of a keel, and you kind of make them think like a boat. They also have a keel to kind of be stable in the water. And I have put this into a different section, and that I will come back to later. So, what is keel bone fractures or keel bone deformities or keel bone damage, as it was described the first times? Well, it's a situation that was kind of discovered. Maybe it didn't start at that time, but it was discovered a couple of decades ago, and it turns out it has a global distribution. And we can see from previous investigation that the prevalence or the frequency in the birds is really high. And when I say alternative systems, that is the systems where the laying hens, they can roam freely with or without access to outdoor areas. When I talk about cages or enriched cages, that is when they are caged so they cannot roam around freely. So the thing is, in the previous literature, in the beginning, then it was, in the beginning it was like a coincidental finding. So it was poorly defined, so it was described as damages or mostly, and then it was also including both deformities and fractures, and I will get back to that later on. Investigations has also found out when we look at the birds during the production period, then they start around peak of lay or begin just before they start peaking, and then they have this fairly sharp or high rising sigmoidal curve over age until it flattens out around 50-60 weeks old, and then it's more or less a stable development. So the majority of the fractures of the birds happen in the period where they are most productive. So Until we started the work then, and also along the way, now there's quite an accumulated evidence that we actually have a huge issue here. And it is actually also by scientists regarded as one of the most important welfare problems in layer industry. And you can see on my last bullet here that I just took a statistic from Færøstat, and we have more laying hens than we have people a year. So it's really a big problem. And if you can say that we have at least 2/3 of the birds have at least one fracture, that's huge. The thing is, we still really don't know much about how it is caused. And the general notion until we did the work that I will tell you about later, and that is also because it was mainly done on live birds, is that it was probably due to trauma or how the houses were furnished and so on, or how if they were landing badly and so on. But what I can tell you in a minute, then we could not really understand that, and then the researchers from all over Europe particularly started thinking, okay, maybe there is another reason, and then we have now proposed that it is a problem of multifactorial origin. That is also when we are talking livestock production and we're talking about production diseases, they are all multifactorial. So it's genetics, it's management, it's some kind of trigger, and that could be trauma, it could also be an infection, in general terms, speaking of production diseases. So, if we just have to kind of put aside the definitions for now, the deformities for now, then we can see here, sometimes we can actually see and palpate them from the very beginning, that these are very deformed. And that is the rim of the keel that is going most ventrally or most to the ground. And there's quite good evidence that it is most likely to originate from pressure on the keel from the perches, and if they have poor perch design. Of course, there will also be some aspects about bone strength and bone mass and feed, because the mineral calcium phosphor level in the feed, and also regarding where they are in the laying period, are also depending on how much calcium is available for the bone. The fractures, on the other hand, they mainly occur in two places: on the very cranial part of the sternum, like here to us, or on the very caudal part, which is like here. Just down here. And actually, it is so that they are best seen or only seen in some cases if you do sectioning or necropsy of the bird, or maybe x-ray. So you can see this is a typical set of manifestations of keel bone fractures. We have one fresh one here, where we have, you can see we have a blood clot. And that is always the case when we have a rupture or discontinuation of tissue. Then we also rupture blood vessels, and we will have a bleeding. Then we have one fracture here that is a little older. We can still see there's some blood in the fracture line. And then now it can go two ways. It can either heal more or less without callus, as we can see over here in the mid-right position, which is a very common manifestation of the caged birds. Or it can be very, very full of callus, as we can see on the two flanks, where we can see big bumps and lumps of callus. And maybe you have all noticed, except from the one in the middle, they have all multiple fractures. So we were a little behind other European countries in Europe, but we actually ended up doing a completely different approach So we designed this study to be a necropsy study, and it was also designed in a way so we could do complex statistics and epidemiology. So we ended up having, and of course that was based on the sample sizes or the population that we needed to address, was based on the results that were previously published. So we ended up, and we wanted to also investigate how is that difference between the production systems, because the previous publications of the previous studies, they kind of indicated there were some favor in terms of low prevalence in the cages. So we would actually see if we could see the same pattern as previously published. So we ended up having 40 flocks at end of lay. Then all the fractures that's supposed to be happening or would have happened would have happened at that time. And then because of statistics and also the expected prevalence, then we investigated 120 birds per flock. So in total, we did post-mortem of almost 4,800 birds, and we used the same method with inspection and palpation as the previous studies. And then we added the necropsy on top of that. And on top of that, we also collected data from the production database from the flocks, so we had actually real life production data. That was also some of the things in the experimental studies previously. Then it was just small population, and then it was really hard to see which factor was kind of dependent or not. So we ended up having more or less a third of each, the enriched cages, the indoor barn-housed, and the organic / free range. It was supposed to be only organic, but then we had the avian flu, and then they were not organic anymore. And then we were also fortunate that we could receive birds from parent stock, layer bird parent stocks. And the production in Denmark, there are not that many producers, so we hope that we could have a fair distribution along the hybrids, but at the end of the day, as you can see, it ended up being fairly skewed. So we had very many birds that belonged to the hybrid Lukman Classic, because that was the most prevalent one at that time. But if you look at the prevalences here on the fracture, they are not that much different on a global level. But I cannot really say something about when we withdraw all the other hybrids as apart from Lukman Classic, then the conclusions are the same as I will tell you for the whole population, the sample population. So the prevalence is very interesting, and you can see if we just go here to the right, then we have like the global prevalences of the four production system, the ones in production and the parent flocks, and then like an overall. And then we can see they are all around 80–90%. And that is just if they have fracture or not. It's not how many fractures they have. I will show you that later. But if we look at the flocks and the distribution within each production system, then we can see, despite that we have very evenly prevalence and no difference in the prevalence between production systems, then we could actually see within each production system or within the whole population, we have considerable flock variation. So you can also see these error bars, they are actually overlapping each other in the four different production systems. And then maybe remember we had a few number of males, none of those had fractures. So that was also quite okay, why don't they have fracture? Even though it was only less than 40 birds, but still it was an interesting observation. If we also very early started, actually from the second flock, we started counting the fractures, because we could see they had more than one fracture. And here we could see a bit difference in the production type. As you can see here, the number of fractures when we only had one fracture, then the majority of the parent birds had only one fracture. But if we go to the worst situation where they had 4 or more fractures, there we could see that actually more than 40% of all the birds that are roaming freely with or without access to outdoor, they have 4 or more fractures. So, and this is quite significant results in that. So, and if we calculate the mean number of fractures, and a total is around 2.5 fractures per bird. So that is something to think about, I think. We also looked at the localization. You remember I had like 2 spots on the keel bone here in the cranial part and in the caudal or distal part, we registered all the fractures that we observed, where they were placed, and also if they had multiple fractures, if they were placed in which of the sections they were placed. And here we can see the results from that. And if we only take the ones where only the caudal or the distal part is involved, then we end up at least 96% of the birds have fractures only here. And if we add on the combination where the distal part is involved, then we are close to 99% of the birds having that part of the keel involved. Then we also looked at how were the morphology of the fractures, and I have called this the Callus characteristics. And callus is the bone repair tissue. So that is the bone that comes when fracture has to heal, and the more stable and immobilized the fracture is, the less callus will be formed. So it's the same if you have just a scar, and if you're not stitched up, you will have a huge scar, and if you're stitched up, you will have a small scar. So, in veterinary medicine, then you can treat fractures 2 ways. You could do it either like you can try to fix it or immobilize it either surgically or with a cast, or you can have what is called conserved therapy, and that is restricted access to movement. And where do we see that in the cage layer production? We do see that in cages. They have restricted access to movement. That is also why that we could see that if we look at the production system, then we could see that the enriched cases, the birds from the enriched cages, then almost 2/3 of the birds had minimal to no callus. And that is, of course, they are standing still and they cannot flip their wings and they cannot run away from their flock mates. It is stabilized. And that is maybe one of the explanations why the previous studies could not palpate the fractures, also because you need to put your index finger like halfway underneath the curvature here, and no live birds really like that. So that is what we can see from the production system. And then we could see that regardless of they were barn-housed or organic or parent birds, then the majority of the birds had moderate to severe amount of callus. If we looked at the number of fractures also and saw where it is in terms of callus formation, then we could actually see, and you can see how it rises, the blue line here where we have moderate to severe callus, that the more fractures they have, a more complex morphology it is, and therefore it's most likely to have less easy to be stable, so we have more callus also in these situations. So that we can see also from a morphological point of view. We also registered the body weight on all these birds, and we could actually see this is a plot, a statistical plot showing individual risk of getting a fracture depending on body weight here to the right, and that is based on flock level. And there we can see that you can see all of them, most of them are going downwards to the right, and that is indicating, or that is significant, that the heavier the bird they are, the less likely it is to get a fracture. And that is significant for the parent stock and the organic. And then there's a trend on the barn house, and then the rich cages. We could not really see a difference here. But if we look at the number of fractures per bird, then we can see a very, very evident pattern for all the production types, that the heavier they are, the less likely they are to have more fractures. So that was the observations we did. So this was all the pathology and morphology that we could find out. And then we looked at the production data, and we have only showing the ones that are of interest, but we investigated, you know, the laying percentage and the egg weight and the mortality and all kinds of stuff during the production. And then we ended up having these three factors which were significant, and that was the age at onset of lay was a very important factor in development of fractures. So to put it into other words, then if a bird or flock were delayed 1 week in starting laying eggs compared to normal, then the prevalence will be reduced by 12%. And subtracting 12 from 86, then you can do the maths yourselves. Then we also did like an estimate, and this is actually it's important for me to say it's an estimated daily egg weight, and it's a proxy for that when a hen starts to laying eggs, it doesn't lay an egg every day. So what we added, the how many eggs it laid the first week, multiplied it by the egg weight and divided by the number of days in the first week. So that is also why, and you will see some of the numbers, they are quite low later on. So it's not really how small the egg is, but it's you can say it as the total distress or stress on the egg laying on the skeleton the first week of lay. And then we could see that the higher the estimated daily egg weight per hen at this period, then it would increase the prevalence. And lucky for us, when we did this risk factor analysis, you saw the nice figures of the body weight. They were also really, really nice here. So you can see that for each 100 grams, the birds are heavier than the average of the population. Then if the prevalence is reduced by 3%. So that is also, we can see, sometimes we can see 500-600 grams in difference within a flock of a bird. And some hybrids are on average bigger or smaller than the others. So there may be something to do here. And if you combine it all, then if you're barn-housed flocks, then you have the highest occurrence if we combine it. So to kind of to investigate whether palpation, which was done previously, was a reliable method, then we also, as you remember, I said that we did both, and there we could actually see that we had very, very different results in both inspection palpation and necropsy. And just to put it in short, this is quite some, you can see the numbers here, that we are wrong quite a few times. To put it in normal wording, then it is palpation significantly underestimates the presence of fracture in a bird, because we cannot palpate these fractures where we don't have any callus formation, and you can only palpate them where you have quite a lot, especially in the live birds. They are really not liking that you are putting your index finger more or less up to the heart. That's so, and then we could also see that the deviation, we also recorded them, and they are not necessarily linked to fracture, but they can maybe be involved if we have very complex fracture patterns in some way. So, is it something new with these keelbone fractures? Because we can see it's very prevalent. So then you start to think, okay, are there any, do we have any control birds? It doesn't seem that we have any control birds in the commercial birds. So what would we do? Then we have some colleagues in Norway who had looked in red jungle fowl, which is a living ancestor of our domestic chickens. And also because actually Darwin, in his variation of animals and plants under domestications, here you can see this is, he could see that he observed some deformed sternums, whether it was deviations or fractures, it doesn't really tell. So if our colleagues set out to investigate this, also because it has never been investigated, and as they are ancestor to the layers, does it occur naturally, and also they had heard about our observations in hens and males, and would that be the same in that kind of birds? So they teamed up with Linköping University, where they have two zoo populations, of red jungle fowl. Oh, I can see it's still in Danish here, I'm sorry. And a white leghorn, which is also a recent descendant or ancestor of our white layers. So they were investigated end of May, and we have two small studies with just a few birds, and I'll go strictly to the results here. That is just for the jungle fowl, and there you can see the hens and the roosters. And you can see the fractures. They did the same approach as we did with the post-mortem. And here you can see, okay, about 8% have fractures of the hens here, and none of the males have fractures when we look at the red jungle fowl. And that is, we have to say, it's a small population. It was just a few birds that we looked at, they looked at here. Then, because they have also a population which is raised the same, housed the same, of these white leghorn birds, which is very close to what we see of the commercial layers. Then they did the same thing to see, okay, because of housing and so on had also been suggested as a factor that could kind of contribute to the development. So they looked at that, and then we could see here that in hens, then we again have around 10% of the birds having a fracture, or at least one fracture, whereas in the layer type chickens here, then it's around 70% having fractures here. And if we look at some of the production data, then we can see that the jungle fowl, they are very old when they come into lay, where the white leghorn are more or less the same as our commercial layers. Then we can also see that how many eggs per week. The red jungle fowl has very few eggs per week in the breeding season, whereas the white leghorn, and this is actually quite low compared to the commercial layer. And then we can also see the egg weight. So that kind of supports the observations that we did, that also that the many eggs has something to do with the development. So what could we learn? Yeah, even though there were small studies, then we could see that there is some kind of occurrence, and maybe the keel bone is a bone that is really hard to keep non-fractured if you are a female and uses estrogen, and estrogen is really used for reproduction. We all know that. And we could also see that despite that they were housed in the same way, then there were differences between the breeds. So that is also suggesting there's a genetic element in this. So why are keel bone fractures so much more prevalent in the modern commercial layer? And that was actually the same question that we asked when we had just had investigated very few flocks in the prevalence study. So what we did, or what has happened to the bird, is that looked into the literature and also the statistics, and the breeding goal over the last 40-50 years have changed. So and that has changed to increase the financial turnover for the producer or the farmer. And what has changed in the bird? Then the sexual maturity has been lowered, so they come into lay much earlier. You can see that it was also the case with the red jungle fowl and the more selected strain as the white leghorns. Then also there's a consumer demand that we globally would like to buy medium large egg levels, eggs. That is our preference. So they have been selected to have this size of egg for the longest period of time. And hence when they start laying eggs, they start laying small eggs. And when they're old, they have extra large eggs. So, and they are not as many Eurocent worth as the one that are medium large. So that has been like an indirect driver for the selection. And then of course you have all heard of that the grain prices are really rising at the moment, and that is actually the most expensive part of producing an egg. So in order to kind of enhance the profit for one egg, because it takes the same amount of energy to produce one egg, and it did so in the 1950s, 70s as well. There's so much energy in an egg. So how can they kind of reduce the amount of energy they have to give to the birds? That is by reducing the body weight. So you can also see, if you look into how the hybrids has developed, then there is a tendency that they have become smaller. Some of the most popular hybrids. We still have some of the larger hybrids. They have different. They have maybe have a little less production rate, so they are less popular, but they can be available. Then a thing that has not changed, you can see from the very line here, then it's the skeletal maturity. The keel bone is just like our skull bones, so it's also made from a cartilage mold or scaffolding. Maybe you have noticed that if you buy a whole chicken for cooking, then half of the keel bone is still made of cartilage. That ossification or development is not finished until the birds are maybe 40-45 weeks old. And that was described already in the 1940s. And we can see that that is still the case. So that has not changed. So skeletal development still take more or less the same time. So how do they occur? And that is one of the questions that we asked ourselves quite quickly while we were doing this prevalence study, and also because we could see, even though that we were convinced there were no differences in the prevalences, also as I showed you, already when we have done very few studies, then we could see there were differences in the morphology. So, and then we thought about, okay, we need to understand these fractures and how they developed. They were all old fractures, so we could not say how old they were. So then Jens Peter Christensen, my professor, he said, okay, shouldn't we go CSI kind of thing? So he contacted the forensic department, because at the forensic department in Copenhagen there is a guy who is an expert in old skeletons and also in old fractures, and how do they repair as well. So, and then we presented our hypothesis and say, okay, is that something that you maybe could help us with? And they were really, really excited about it, and already at the first meeting they suggested that, okay, maybe we were kind of thinking, oh, we will do just histology and so on. No, say, we have a CT scanner down in the basement, and when we are done with our duties, then we can actually do research if it is for the benefit of the society. So we start the scanning on this CT bed here of the birds, and then we of course we did a pilot, so we could see how should we select for the study that we wanted to do. So we scanned some birds, and then we ended up scanning some keels, because that was our bone of interest. And now I will show you a set of pictures, because what we can do when you have CT scan, then you can do some image analysis and 3D modeling, and then you can actually turn them around to see even little crevices or smaller amounts of callus. So we can see this is a perfect fracture, and we can also see there are almost no deformation on the ridge of the keel, the crista. And then we can see that here that is looking a bit lumpy here, and from one of the X-ray CT scan is just a number of X-ray where you can put them in, so you can make these 3D models. Then we can see this should have looked like this all the way, but we can see a huge amount of callus, and if we count, then we have 1, 2, 3, 4, at least 4 fractures here. And we could see some also where they were fractured in the cranial or the mid part, and we can see it looks very complex, and sometimes very deformed, sometimes so deformed that they will never heal, and also we have this called pseudo-articulation, so it will still be moving even though it's supposed to have healed. And they could really be deformed. And all these very deformed ones are from barnhoused or organic flocks. Then we also, of course, had a group of keels from cage layers, and there you can see then the fracture morphology is looking completely different. All 3 of these keels, they have actually fractures down here, but they are really hard to see for the inexperienced eye. This is a bit easier, but this actually have a very small one on the tip. Next to that, we also did histology, both with routine staining, so we could see how connective tissue and scar tissue and bone is looking, but also some special stains that could say something about how mature the callus or the bone is. What was really evident from the whole thing is that when we looked inside the bone, they were not really healed at all. And the fracture line was simple, and it was opening towards the muscle, and that all indicates that the force of fracture is coming from the inside, you have to remember if you break a pencil, when it breaks, put the force and then it breaks on the opposite side first. That is how it is. And if you have a traumatic fracture, then you will have a complex branched fracture pattern. We had only one line. So we could not make it to fit that it was caused by trauma. And the direction of all the fractures, they were looking very uniform. So that we could look into. We could also see that we also did that on young birds. And here is just, you can see there are more colors on the old birds compared to the young birds. And that is also, it's a visual way of presenting that the older the birds they are, the more complex fracture patterns they have. So the fewer the fracture, the younger the birds, the fewer the fractures, and they are also less ossified. We can see here, we have this cartilage here where we have the old one here. And as I told you, they do ossify late. There may be some line or breed differences or management differences. That has not really been investigated. In the very beginning I told you that most of the fractures, they occur in week 25 to 50 of age, which is also coinciding with the peak of lay. So then the next research questions pops up. What the morphometric analysis of the biomechanics of the egg laying process, how is that? And also, what are actually the ultrastructure in terms of cells in the ossification status? And that is something that I'm doing right now, so I have nothing really to tell about that. But are there any, is this ossification zone, is this a weak spot or not? We really don't know, but we know if we have immature bone matrix, even though regardless if it's repair tissue or just young tissue, then we can see that they die differently when we do this special stain. So I'm trying to understand if we have this a weak spot in the ossification zone yet. So that is to come. So I have some final remarks. So this study, the first study I told you about, that's actually the first study to identify risk factors based on real production data. And we also, with the CT study here, proposed a potential pathogenesis that is actually coming from the inside of the bird, which has contributed to the notion maybe it's a more multifactorial thing that we have to look, instead of looking at the environment where the bird is. So, and as I see it, then we have at least two ways forward towards reduction. Then of course we need to systematically evaluate these identified risk factors if we can do it. The risk factors, they are based on data that has already happened. So if we want to say this is how it is, then we have to do like we say and get the same result. So that is we need to see if we can control, if we can, for instance, by management, get the layers to start later in lay. And then, as the CT studies indicates, also the jungle fowl studies indicates, then maybe there is some fracture resilience or resistance when we think of the genetics on that. And that is a really hard nut to crack because it's really a lot of money for the two breeding companies that are globally. And then, as I ended up, what is the role of the ossification? And then there's a thing that I have not addressed, and that is not because I don't want to address it, it's just we don't know how to assess discomfort or pain in a bird that are so effective that it can lay eggs even though it may be sedated. So That is a thing, and also because the bones are not weight bearing, so it's really, really hard to assess. It's also an animal of prey, so they also don't show signs of weaknesses before they are most likely to be beyond the point of no return. So with that, I will thank a whole bunch of people, in particular the Danish egg farmers. They are really, really the ones being the bravest here, letting us get into the whole thing. So, and then a lot of other experts. But the Danish egg farmers, they are the heroes here. Thank you.